Example 1, make a chart of values and graph the relation x comma y and indicate the direction of movement. We need t to be in between -2, and it can include -2, and +3. Now we're going to take -2, substitute it here for t, and then that will give us the x value at that point in time. So -2 minus 3 is -5. Take -1, substitute it for t, we get -4, and so on. Now we're going to take -2, substitute it here for t, and then square it. -2 in parentheses squared, that would be 4. -1 in parentheses squared, that would be 1. And then just keep following that pattern. Now we only need to plot x and y. So I'm going to do that now. We need to indicate the direction of movement. So we're going to draw continuous arrows showing us which way this graph is going. And now example 2, we need to find the rectangular equation with restrictions and graph the parametric curve using this equation. All right. We're going to have 3 columns here. This is how I would start. Now for t, they tell us t has got to be greater than or equal to 0. I would then check your equations. If one of your equations has a square root, well, then be strategic about what numbers you're going to use. You want to use perfect squares. So we're going to use 0, 1, 4, and 9 because those are all perfect squares. Now to figure out what is the x value at 0 seconds, we would then take 0, plug it in here, do the math, and that would give us the x value. So plug in 0, the square root of 0 is 0, and 0 plus 2 is 2. Plug in a 1, square root of 1 is 1, 1 plus 2 is 3. Take a 4, plug it in, square root of 4 is 2, 2 plus 2 is 4. Square root of 9 is 3, 3 plus 2 is 5. Now let's take our t values, plug them in here for t, and that will give us our y equivalent. 0 for t, 6 minus 0 is 6. 1 for t, 6 minus 1 is 5. Plug in 4 for t, 6 minus 4 is 2. Plug in 9 for t, 6 minus 9 is -3. Let's plot these. We don't need the t column anymore. So 2, 6. 3, 5. -3. Then make sure you indicate motion. Now let's go back to the beginning. Find the rectangular equation with restrictions. Anytime, not anytime, but most of the time, whenever we're graphing a function, doesn't it start with y equals, like y equals 6 minus t, or maybe y equals x squared, and then we can graph it. Use that as an indicator of where to start. Y equals 6 minus t. Okay, this is the equation that we're eventually going to work with. But what we have to do is we have to take a look at this equation first. We have to solve for t. We have to get t by itself. I'm going to rewrite this equation as the square root of t plus 2 equals x. It's the same thing. I just rearranged it because whenever I'm solving for a particular variable, I prefer for it to be on the left side of the equal sign. Now, in order to get t by itself, subtract 2. And now to eliminate the square roots, we're going to square both sides. We now have t all by itself. So what we can do is, now that we know what t is, we can plug it in. We can use substitution. So we have y equals 6 minus x minus 2 squared. We're more used to seeing it written in this manner, however. And this is the rectangular equation that would produce this graph. However, if you were to plug this into your calculator, you would get a parabola. There would be another side going this direction here. This is the accurate model of the graph, however, because we have graphed it with restrictions. But this is the rectangular equation that would help us with that graph.